Hi everyone. In today's video, we are going to learn one of the important topics in organic chemistry, SN1 and SN2 reactions in a very simple way. Let's start it. Here, in this video, first we will see what is substitution reaction. In a substitution reaction, one atom or group of atoms in a molecule is replaced by another. There are three common types of substitution reaction. In that, one is nucleophilic substitution reaction, second is electrophilic substitution, and third one is free radical substitution. In these three types, we will learn what is nucleophilic substitution. See, in for substitution reactions, but key point is one part leaves, that is called leaving group, and another part takes its place, that is called nucleophile. Now we'll see what is nucleophilic substitution reaction. A nucleophilic substitution reaction is a reaction where a nucleophile, that means electron-rich species, replaces a leaving group in a molecule. So, we'll see what is a nucleophile. A nucleophile is a species that has extra electrons, wants to donate electrons, attacks a positive or partially positive atom, usually carbon. Example OH minus, Cn minus, NH3 and Cl minus. These are examples of nucleophile. Now we'll see the general reaction. Rx plus nucleophile gives rise to Rnu plus X minus. Here Rx is a substrate that is called alkyl halide and Nu minus is a nucleophile and X minus is a leaving group. Example Cl minus, Br minus and A minus. Now what is substrate? The compound on which substitutions takes place is called a substrate. Here in this general reaction Rx is a substrate. Here substitution takes place. Now we'll see what is leaving group. The group that becomes displaced from carbon taking the electron pair with it. The leaving group usually leaves as an anion but sometimes also be a neutral molecule. Example, say CH3Br plus OH minus gives rise to CH3OH plus Br minus. Here is replaced by OH minus and you got CH3OH methanol. Then you got a leaving group as Br minus. Here OH minus attacks carbon and replaces Br minus. Now we'll see in nucleophilic substitution reactions there are two important types. One is SN1 reaction and another one is SN2 reactions. First we will see what is SN1 reaction. SN1 reaction means substitution nucleophilic unimolecular. Here the reaction proceeds in two steps. Step 1, leaving group leaves, forms carbocation. This is slow step, also called rate determining step. We'll see the general reaction. Rx gives rise to R plus X minus. Here R plus is carbocation intermediate. So, in step 2, nucleophilic attack takes place. This is the first step. See, R plus carbocation intermediate plus nucleophile gives rise to Rn. This is the nucleophilic attack reaction. This is the second step of SN1 reaction. Here, what are the key features of SN1 reactions? Actually, here rate depends only on substrate. Rate is equal to K into Rx. So SN1 shows first order kinetics. Why rate depends only on substrate? So SN1 shows first order kinetics. Occurs in tertiary alkyl halides. And then third is carbocation is found as intermediate. And also it can give racemic mixture. So think first leave then attack. Here first halide will leave then nucleophile will attack. So it forms in two steps. Next, we'll see the example. In SN1 reaction of tertiary butyl bromide with water. See, in first step, ionization means carbocation formation. This is the slow step. See, here example given CH3 tri C CBr gives rise to CH3 C plus Br minus. In step 2, nucleophilic attack. will takes place. This is the fast step. So CH3 thrice C plus H2 gives rise to CH3 3COH plus H plus. See here nucleophile present in a solvent form. This is called solulysis also. So you'll see the energy profile diagram of SN1 reaction. Here you'll see, here you can see the two peaks. Here the graph, here the graph has drawn like a energy versus reaction coordinates. See here first peak, in first peak, here in first peak carbocation formation takes place. This is slow steps and arduous steps, and in the middle value carbocation intermediate will form. And in the second peak, here nucleophilic attack takes place. That will be fast. So two steps is there. We will get two peaks. Next, we'll see what is racemic mixture in SN1 reaction. A racemic mixture is a 50 is to 50 mixture of two enantiomers, R and S isomer, that is mirror images molecules. SN1 follows both racemization and inversion. So, what happens in SN1? In an SN1 reaction, the leaving group leaves forms a planar carbocation. This carbocation is flat and sp2 hybridized. So, the nucleophile can attack from both sides, that is from front and back. Both side attack takes place. So, in that result, because attack happens from both sides, one product has formed as retention of configuration, another product has formed as inversion of configuration. So you get equal amounts of both enantiomers, that is called racemic mixture. Now see the example. Consider 2-bromobutane that forms carbocation and then attacked by a nucleophile. Here products formed as one isomer R and one isomer S. Final mixture is equal to racemic mixture R plus S in equal amounts. Now we'll see. SN1 gives racemic mixture because of planar carbocation intermediate, allowing attack from both sides. This is the theory of SN1 reaction. Now we'll see the SN2 reaction, that is substitution nucleophilic bimolecular. This happens in one step, that is single step reaction. Here nucleophile attack from back side and leaving group leaves at the same time. So it is a single step reaction. Now we'll see the general example. Rx plus Nu minus gives rise to Rnu plus X minus. This will happen in a single step. So we will see the example. CH3Br plus OH minus gives rise to CH3OH plus Br minus. Here key feature is single step reaction and backside attack and inversion of configuration takes place. See here rate depends on both substrate and nucleophile. R is equal to K of Rx into nucleophile. So SN2 follows second order kinetics. Usually this occurs in primary alkyl halides, causes inversion of configuration. Think attack and leave at same time. Their first halide in SN1, first halide will leave, then nucleophile will attack. But in SN2, attack and leave at the same time. Now we'll see the energy profile diagram of SN2 reaction. See here we see the single peak. See, because single step reaction, bond breaking and forming happen together. So one step is equal to one peak. Now we'll see the factors affecting SN1 and SN2 mechanism. First is nature of substrate, structure of alkyl halide. In SN1, stability of carbocation is a key step. Here tertiary is greater than secondary and then primary. Here best is tertiary. In SN2, steric hindrance matters. So primary is greater than secondary than tertiary. So here best is primary. First one, what the first factor is nature of substrate. Next we'll see second one is nucleophilic strength, nature of nucleophile. In SN2, weak nucleophiles also work. That is example H2 and ROH because carbocation already formed. In SN2 needs strong nucleophile that is OH minus, Cn minus and I minus. Here direct attack required. So SN1 favors weak nucleophile and SN2 favors strong nucleophile. Now third one is nature of solvent. In SN1 favored by polar protic solvents. Example H2O and alcohol. Stabilize carbocation and leaving group. This will stabilize the carbocation and leaving group. Next is SN2. This is favored by polar aprotic solvents. Here proton source not required. In SN1 proton source required. Example DMSO and acetone. Here this solvent keep nucleophile strong. Now you see the nature of leaving group. In both SN1 and SN2 reactions, better leaving group is equal to faster reaction. So order is equal to I minus, Br minus, Cl minus and F minus. Now fifth one is the steric hindrance. In SN1, steric hindrance is not very important because carbocation already forms. So stability order is bulky group always having first priority. In SN2, steric hindrance is very important. If bulky group presents that block backside attack. So in SN2, steric hindrance is most important. Next, sixth is carbocation stability. Here, this carbocation stability matters only in SN1. More stable carbocation, faster SN1. So stability order tertiary, secondary, primary, and then methyl. Now, we see the important concept. See, benzylic and allylic halides undergo SN1 reaction because of stability of carbocation due to its resonance. Example benzyl bromide and allyl bromide. And same way, vinyl halides and aryl halides do not undergo SN1 reaction because of instability of carbocation. Understood? Next, we'll go to seventh factor, that is nature of concentration, that is kinetics. In SN1, that SN1 depends only on substrate, so that is called SN1 follows first order kinetics, and SN2 depends both on substrate plus nucleophile. Rate is equal to K of Rx plus nucleophile. Next, let's see the revision stick. SN1. In SN1, carbocation forms, weak nucleophile required and protic solvent required. And in SN2, strong nucleophile required, less hindrance required, and aprotic solvent. Now we'll see the quick comparison. First is kinetic order. In SN1, first order required, and in SN2, second order. And rate law. SN1 rate is equal to K of Rx, that is only substrate. In SN2, rate is equal to K of Rx into nucleophile. It depends on both substrate and nucleophile. Next, see the mechanism. S11 is N1 is two step and SN2 is one step. Now we'll see the intermediate formation. SN1 carbocation present. In SN2 there is no intermediate. And in substrate preferences, SN1 tertiary greater than secondary, and in SN2 primary greater than secondary. We will see the nucleophile. SN1 favors weak or neutral nuclei, and SN2 favors strong nuclei. And we'll see the solvent. SN1 required polar protic solvent, and SN2 requires polar aprotic solvents. Example DMSO and acetone, and for polar protic solvent H2 and alcohol. Now we see the stereochemistry. SN1 requires, and in SN1 racemization will form. In SN2 inversion product will form. Next we'll see the rearrangement. In SN1 rearrangement possible, but in SN2 rearrangement not possible. And final super short memory line is SN1 is equal to 1 molecule rate, 2 steps and racemate. And SN2 is equal to 2 molecular rate, 1 step and inversion. I hope you understood these concepts. If you like this video, please like, share, and subscribe to my channel. In next video, I will come with some more important topics from organic chemistry. Thank you. Have a good